Hello friends, in this video you are seeing a very long question and it is related with the parallax. Parallax concept can be used to measure the celestial distances. Now some stars or some planets may be nearer to Earth than and some stars may be away from the Earth, or we can say they are at the end of universe but they are visible. So some stars are close to Earth and some stars are away from Earth. If you observe those distant stars which are at the periphery of the universe, they are appear to be at the same location. It is somewhat like that if you are traveling through a train and you are watching the distant mountain, so distance mountain is running with you, whereas the nearby trees are changing their position. So the distance objects do not change their position if you change your observation position, but the nearby objects change their position when you change your observation position. This concept is called parallax. So we will use the parallax concept to measure the distance of a star. So for that, what we will consider a star as first and the distant star as dash. Now you can see this is the sun and this is the earth, and earth is revolving around the sun in a circular orbit like this. Now suppose in the month of January earth is positioned at A and you are observing the star S with respect to a distant star S dash. You can consider the S dash is at the periphery of the universe. It is much away from the S compared to S. So whether you are observing this S dash from A, it will appear to be at the same location. Suppose you are observing the same S dash from the location B. Of course you are observing from the earth, but earth is revolving around the sun. So after 6 months the earth will be at B position and again you are observing the same distance star S dash. So what your observation that S dash has not changed their position. So position of S dash is not changed and S dash is situated at the periphery of the universe, but they are visible from the telescope. So earth is at a position maybe in the month of January, and after 6 months earth is exactly at the diametrically opposite position B, because earth is revolving around the sun like this. And though earth has changed its position, but the star S dash is appeared to be at the same location whether you are observing the S dash from A position or B position. But the star S, which is much closer than S dash from the earth, it has shifted its position. That means when you observe the S dash and then you are observing simultaneously the S also, so you find that there is some angle between this line of sight and this line of sight. Let us consider this angle is theta 1. This is the parallax angle and it is given that this parallax angle is of the order of 1 arc second or 1 second of arc. So this theta 1 is the order of is 1 arc second. Now when after 6 months you are again observing the same star S from position B with respect to the distant star S dash, then this angle is again the theta 2 angle. Note that first you are observing the star S from A position in the month of January with respect to the distant star S dash. This angle, parallax angle, is theta 1. Again you are observing the same star S with respect to the distant star S dash, and again this angle is theta 2, but it is given that this angle is of the order of 1 second of arc, 1 arc second. Note that 1 arc second is equal to 1 degree divided by 3600. So you can imagine how much is the 1 arc second. Now S dash and S dash, these both line of sights are parallel to each other because S dash is at the what we can say at the periphery of the universe. If I draw the parallel line to this both line of sight, so this angle will be again theta 2, this angle will be equal to theta 2, and this will be theta 1, and as both the angles are of the order of 1 arc second, this complete angle will be equal to 2 arc second. Now there is one more concept, the distance of Sun to Earth. I am showing with blue color. This distance is 1 AU, 1 astronomical unit, and so this radius of this orbit of the Earth is 1 astronomical unit. That means the distance between B to A is 2 astronomical unit, 1 astronomical unit from this side and 1 astronomical unit from this side, because we have considered the position B is exactly diametrically opposite to A. Now we have to find the distance SB or SA from the Earth. So here we can use the angle in radian concept. So angle theta 1 plus theta 2, which is equal to 2 arc second, this is equal to 2 arc second. So we can say angle 2 arc second in radians. Of course this formula is very applicable when the angles are expressed in radians, will be equal to arc length, arc AB divided by the radius, that is BA, or radius SB or SA. So I write AS, or let us write SB, the distance SB. Let us represent the distance SB with the letter R. So this letter is suppose R. So let us represent this as R. One more thing here before conversion, there is a unit called parsec. Okay, so try to understand that the length we have to find the SB. We have to find the SB. Now arc AB is equal to 2 AU, approximately 2 AU. 2 AU means the distance between, it is the 2 times the distance between Sun and Earth. Distance between Sun and Earth. So arc AB is equal to 2 AU. What is AU? AU means astronomical unit. It is a 1 AU is approximately equal to distance between, it is the average distance between Sun and Earth. So the arc AB is approximately 2 AU. It is the twice of 1 AU. Then distance SB, let us consider this as distance R, which we need to find here. We have to find this distance, and this is in radians, that is 2 arc second. Now we can represent the arc, the radius, the distance R, the distance of a star from the earth, as 1 AU, which is creating the angle of 1 radian. When we divide the both this expression with 2, if I divide this expression with 2 from both sides, we get the R is equal to 1 AU upon 1 arc second. Now actually this distance, or the distance 1 AU and 1 arc second, if I show separately like this, sorry, it is the angle 1 arc second, and this is the arc 1 AU. Then this distance is called 1 parsec. It is a new unit of distance. Again, it is used for the celestial bodies, distance between two celestial bodies. So this distance is nothing but 1 parsec. So actually the nearby star will be at the position of 1 parsec if this angle is 1 arc second and this angle is also 1 arc second. Now let us convert the 1 parsec into meters, because parsec represents the distance, and as discussed, it is a distance of a nearby star. It is a distance of a nearby star as which is creating a parallax of 1 arc second with respect to a distant star S dash. And as we have generated the formula for 1 parsec is equal to 1 AU upon 1 arc second. So let us convert this into the meters. 1 AU is equal to 1 astronomical unit. It is the distance between average distance between Sun and Earth, and it is given as 1.496 multiplied by 10 raised to the power 11 meter. So we have the 1 AU in terms of meter, and let us convert the 1 arc second in radians. So that will be equal to 1 divided by 3600. It will be converted into degrees. Then it should be multiplied with pi upon 180, because actually these are degrees, and then if you have to convert into radians into degrees into radians, you have to multiply it with pi by 180. Degree and radians. So conversion of degrees into radians, it has to be multiplied with pi by 180. You can verify this. Degree, radians, 180 degree means pi radians. So 1 upon 3600 degrees, that will be equal to 1 upon 3600 multiplied by pi divided by 180. So according to this will be in the radians format. Now let us solve for R. R is equal to in meters. We are solving in meters. 1 AU divided by 1 arc second in radians. So it is 1.496 into 10 raised to the power 11 divided by 1 arc second in radians, that is 1 upon 3600 multiplied by pi divided by 180. Let us solve it further. It is 10 raised to the power 11. So it is 1.496 multiplied by 3600 multiplied by 180 divided by pi multiplied by 10 raised to the power 11. After solving 1.496 multiplied by 36 multiplied by 18 divided by pi, 3 zeros are left, that will be added with this 3, that is 10 raised to the power 3 multiplied by 10 raised to the power 11. That will be equal to 1.496 into 36 multiplied by 18 divided by 3.14 multiplied by 10 raised to the power 13. Let us solve further. So there is a small correction here. It should be 10 raised to the power 14. If I solve this bracket, these terms, it will be 308.5721 multiplied by 10 raised to the power 14. If I shift this decimal point here, that means I have to divide by 100 and multiply by 100. So it will be 3.085721 multiplied by 10 raised to the power 14 multiplied by 10 raised to the power 2. Divide by, this is divide by 100 and it is divide by 100 and it is multiplied by 100, that is 10 raised to the power 2. So answer will be 3.0857 into 10 raised to the power 16 in meters, and we are solving for 1 parsec. So again come back to our question. If star S is creating the parallax angle of 1 second of arc with respect to a distant star S dash, then its distance from the earth, whether it is at the position A or at position B, the distance of that star will be 1 parsec, and 1 parsec is equal to 3.0857 into 10 to the power 16 meters. Thank you.